This is a picture of our situational awareness screens. What this does in the top left-hand side of the screen, that is the entire system by service center broken down in the little lines below it, and this is how they wanted it to look, so that's how our distribution guys want it. And we calculate our SAIDI and our SAIFI and our CAIDI every minute. And so those are the calculations that are on the right-hand side of that upper screen. Below are graphs. This is graphs of particularly the beginning of a storm. In the third from the left, you'll see a graph that looks like it's an inverted horseshoe, and then you'll see a red and a yellow line spiking up. It's naturally right as the crews were leaving for the day. The storm came in, and so we were shorthanded and had to get crews in. And then on the far right-hand side panel, you can see those are all our outages. What we can do with that screen is it's fully interactive. It lives on a big, huge wall in our distribution control room or on any one of our computers if you have access. But you can literally hover over one of those cases of outage, and you can see all of the case details of that outage, everything you might want to know. That's a zoomed-in version of the geospatial screen you just saw. The little red dots are power out notifications. The little smiley faces are crews that are on trouble. The other crews are crews that are on trouble. They're en route. They've acknowledged. And what we've used this for, we have had a very big philosophical debate within the organization is who owns the crew at the time of trying to recover for an outage. The service area directors, we have smaller service areas in our service territory. They'll say we own the crews. And the distribution control room says I'm responsible for SAIDI. I own the crew. So what we've been able to show by knowing exactly where the crews are and where the trouble is at the time, we've been able to now route the crews in a better way. And everybody has agreed that, yep, the distribution control room has the best information. We'll let them route the crews to the trouble. And that has improved our performance incredibly. This, again, is a blow-up of the situational dashboard, just drawing attention to how we calculate our SAIDI and SAIFI. It is built the way that our controllers wanted to look at it. They understand that we have combined outage and mobile data information in here as well. There is a weather feed. It didn't make this set of slides, but we do have a weather feed that comes to this slide as well. And we also have hover capability here. And then we can get the phone numbers of all these people that are listed as supervisors or working at the time. We mentioned petabytes, Larsh did. We've realized that we're a petabyte company now. What this slide shows is a real-time monitor in our telecoms control center. We read the cell relay system logs, the takeout point system logs in our system, and I understand our system is Itron mesh network, so we go from the meter to the cell relay to the takeout point over microwave or fiber back to our home shop. And this dashboard, they love it to look empty with nothing going on. There's a little bit going on the bottom, but if there's something happening on those top two screens, they're very upset about it in the telecoms control room. But what we're doing is we're using streams to read data in real time. So we are actually processing terabytes of data every 5 seconds. And we do that so that we can understand what's going on in these system logs. And it's not necessarily easy information to digest, so we had to have some good data scientist programmer types go through it, do the mathematical calculations that could show the graphs that you see here. We've now gone so far, if certain situations happen enough, we realized the guy was doing the exact same thing all the time. Now we've automated that action. We've automated action so we can remote control devices to have them flip from one communication channel to another. We've also configured our system that we can remote alert trucks and send the work directly to them. This is a geospatial view of our telecoms. It looks what we call the star diagram or the fireworks diagram. It lets you know, from the takeout point would be the center of the star, if you will. The cell relays would be the communication path they're on. Are they on their primary, or are they on their secondary, or are they down? And that is also in real time. And we now also have geospatial insights of the crews, and so we can literally place the crews on the map and tell them where to go. And if I don't have a view of it here, but we can actually zoom down to the Google Earth view and show the crew exactly what he's looking at in terms of this is where the device is, this is where you need to go look for it. So this is our path. This is where we hope to go. We kicked off analytics in 2011. We refined our methodology and began installing our foundations. We've gone to real-time situational awareness and transformer load management and equipment load management. We're moving to advanced, we've already done it, but we're moving to advanced situational awareness with weather. We now want to get to predictive with weather, predictive damage, and then in pre-placement, of course. So the FinReg initiative you see there, I'll be more than happy to answer questions about that on with separate email or anything else. And we're deploying the same things that we've already done for electric to our gas and gas ops and fleet group. And then the next action is automated orders. We want to get to 85 to 90% automation to the extent we can. And so At the end of this year, we're implementing a advanced distribution management system. Once we've implemented that system, we will have automated switching in the field, but the crews rightfully want to make sure they can trust that the switch is in the position it is, so we will be responsible for coming up with additional analytics, other information to show, indeed, it switched from its out of normal position to another, it's safe to work on it. I won't spend much time here. These are the benefits that you can expect to receive, and I think any utility of any size would receive these benefits. I will say one thing, that having the financial unbilled process for us running in automation with no hands touching it made our auditors very happy, and that made our regulators very happy. So a lot of very difficult questions we used to get in the regulatory rate-based process we didn't get anymore. So that has provided us a tremendous amount of benefit. We're also reducing the number of miles our crews are driving. We're improving their effectiveness in the field. And for anybody starting out on this, make sure you work on your communications if you're going to have a wireless system. If you're going to have a remote system, make sure you have the communications in front of the metering. That's everything. I can tell you that from today, we've had troubles because our secondary communication system, which is AT&T, went down all across Harris County. And so we have had difficulty communicating because several of our sites have been on secondary, and some of them have ran off if they couldn't talk to us. So it even affected our orders that we go to the market. So communications is everything. This is to show you that there's not one box solution. I've mentioned eMeter. We also use IBM Pure Data for operational analytics. They used to call that ISAS. We use streams. I mentioned it, and Tivoli. We're using business objects. We're using data services to move data back and forth. EAI is the old CBON product. We're also interfacing with our legacy systems. So there are an awful lot of systems that have to work together. But what we try and do is our approach is let's write the data once and then read it many times. So we correlate data from multiple sources, and we leave the correlated results in one location, but we leave the source data where it should stay in its source. The next slide. I have to show that because we were a $200 million DOE grant recipient that helped us get our Smart Grid program completed earlier and move into the intelligent grid. So I have to show this slide, and I've done it, and I'm open for questions now, Jesse.
Thank you, Bill. Great job. That was Bill Bell from CenterPoint Energy as we discussed the start small approach to data analytics. And as you just heard, starting small doesn't mean you can't accomplish big things, as CenterPoint continues to do. I'm Jesse Berst of Smart Grid News. I'm your moderator. We're going to answer some questions now, and I'm going to start with this one. Bill, you showed one screen on a map, right, with the little red dots that's showing your outages. And then I saw another slide where you had, up in 2015, you had something called Next Best Action. Are you currently able to prioritize all those red dots, or are there analytics that do now or that you hope will be able to help you with that ranking?
Jesse, what we do is right now we prioritize by number of customers associated with a piece of equipment. So those red dots you saw were individual power out notifications. They had not rolled up to a case. When we get our new outage system, we hope they will roll up faster than our current legacy mainframe system, which is 28 years old. So we hope we'll be able to localize faster with the new system. But not just knowing where things are, I mean, that we know where things are in real time. And so we actually were sending crews, because we had quite a clump of red dots, so that was probably a fuse, not just a transformer outage. So we were already sending crews that direction to work on a line fuse even before the outage case had been created.
So Chad wants to know who, and maybe I'll ask Larsh to chime in too, Bill, after you answer, because he wants to know who owns analytics. Is it IT? Is it operations, engineering? How's it work at CenterPoint? And then, Larsh, how have you seen it working elsewhere?
How we've done it at CenterPoint is I am in the electric business. We think as we've reorganized our company, I'm about to move to a shared services business, but I am considered a client. So I am a representative of the business. IT operates as the other half of the baseball to my side of the Moneyball analogy. My group is responsible for going out to our constituent clients, which I would call distribution, dispatching, distribution operations, the fleet, whoever. And I view them as a client, and we deliver to their vision. Whatever that vision may be, we help deliver to their vision, and then we handle all the IT stuff in the background. We take care of all that for them.
And Larsh, how have you seen it elsewhere?
I think that's a good best practices sort of approach. I think the important thing is that the business have real drivers and people focusing on it. And if we look at that top impediment to this process as being the number of skilled people to work with the data. Those skills are coming from people who are used to not only the business process and the technical issues, but also can get hands-on with the data through the tools. And typically IT provides support for that in terms of the infrastructure and administration, but the people who are going to actually be driving the value will come out of a business organization that can actually focus on the specific problems they're trying to solve.
Mm-hmm. Well, I wanted to do one more here before we head on, and Goran wants to know if Bill can share some of his requirements on his communication systems, like latency, bandwidth, uptime, anything you could share that would help him in terms of knowing what he needs for his own system.
Sure. I think one thing I'd like to have you do is get with me offline so that I can answer some specific details with my telecoms guys in the room. Okay. They know those details better than I do. Like I said, we did go with the RF LAN mesh network system. That is the slowest part of our communication strategy. We went with a GE WiMAX high bandwidth radio from the cell relays to the takeout points. That one has been very productive, very good use in that system. We have had to use GPRS through AT&T and Verizon, and that has been the most spotty, frankly. That we have had issues with them quite a bit. And even though we're fairly condensed, we're only a 5,500 square mile service territory, so we're fairly condensed. We still have areas that are remote, and it didn't make financial sense to put cell relays at every endpoint. So some of them only have GPRS, so when they go down, we're not speaking to them. And so we still have 11% of our service territory that is only on GPRS. And so when AT&T went down today, that actually hurt our read rate, which is usually 3 nines. That hurt our read rate today. So and then service orders couldn't connect and that sort of thing. So that's one thing, is to figure out what your communications will be. And I would welcome a chance to hook you up with our specific telecoms guys, and they can tell you the protocols and everything about it.
Terrific. That's very helpful. This is Jesse Berst of Smart Grid News, and today we're discussing some real-world lessons learned about data analytics.